Welcome to What Is, the channel where we ask the important what is questions. And today's question is, what is quantum computing?
In this video, we're going to break down the basics of quantum computing, explain how it works, and why it's one of the most exciting fields in modern technology. Whether you're a tech enthusiast or just curious about the future of computing, this is the place to be.
Let's dive into the world of quantum computing.
What is quantum computing? First things first, what exactly is quantum computing? In simple terms, quantum computing is a type of computing that takes advantage of the strange and fascinating principles of quantum mechanics to process information in ways that traditional computers cannot. Traditional computers, like the one you're probably using right now, process data as bits. A bit is a basic unit of information that can either be a 0 or a 1, representing two possible states.
These bits are the foundation of all the calculations and operations a classical computer performs. Quantum computers, however, use quantum bits or qubits, which are fundamentally different from bits. A qubit can represent both a 0 and a 1 at the same time, thanks to a quantum property called superposition.
This allows quantum computers to perform many calculations simultaneously, which is a huge advantage over classical computers when it comes to solving certain types of complex problems. Superposition. The key to quantum computing. Now that we know quantum computers use qubits, let's explore the first major concept behind quantum computing: superposition. In classical computing, a bit can be either 0 or 1, but in quantum computing, a qubit can be in a state that is both 0 and 1 at the same time, thanks to superposition. It's as if you're flipping a coin, but instead of landing on heads or tails, it's in a state where it's both heads and tails at the same time. This property gives quantum computers the ability to store and process a massive amount of information in parallel. To put it simply, while a classical computer would need to run through each possible solution one by one, a quantum computer can explore many solutions at once. Imagine you have a maze to solve. A classical computer would have to try each path individually, but a quantum computer could explore all possible paths at once, potentially solving the maze in a fraction of the time. Entanglement. The mysterious connection between qubits. Next, let's talk about another fascinating concept in quantum computing: entanglement. Entanglement is a quantum phenomenon where two or more particles become linked in such a way that the state of one particle directly affects the state of another, no matter how far apart they are.
When qubits become entangled, the state of one qubit can instantly influence the state of the other, even if they are on opposite sides of the universe.
This might sound strange, and it is, but entanglement is what makes quantum computing so powerful.
It allows qubits to work together in ways that classical bits simply can't, making quantum computers incredibly efficient at certain tasks, like factoring large numbers, searching through vast databases, and simulating complex systems. For example, if you have two entangled qubits, changing the state of one qubit will immediately change the state of the other qubit, even if they're on opposite sides of the world.
This can allow quantum computers to perform calculations in ways that are exponentially faster than classical computers. Quantum speedup. How quantum computers solve problems faster.
So, why do we care about all this?
What's the actual advantage of quantum computers? Well, the answer lies in quantum speedup.
Because quantum computers use superposition and entanglement, they can process many possible outcomes at once.
This allows them to solve certain types of problems much faster than classical computers.
Problems that would take classical computers years or even centuries to solve could be tackled in mere seconds or minutes by quantum computers.
For example, quantum computers could potentially crack encryption codes that are currently considered unbreakable by classical computers.
This is because quantum computers can quickly calculate large prime factors, a task that would take a classical computer a mind-boggling amount of time.
Another example is optimization problems. Whether it's finding the best route for a delivery truck, optimizing stock portfolios, or designing new drugs, quantum computers could provide solutions much faster than classical systems, opening up new possibilities for industries across the world. How quantum computers work. Qubits in action. Let's take a step back and talk about how quantum computers actually work. In a traditional computer, bits are manipulated using electrical signals.
In a quantum computer, qubits are manipulated using quantum gates,
which perform operations that change the state of a qubit. These quantum gates work by applying precise amounts of energy to qubits, causing them to enter superposition or become entangled with other qubits. The basic idea is that quantum computers perform computations by applying a series of quantum gates to a set of qubits. These gates modify the quantum state of the qubits, and through interference, the quantum computer eliminates incorrect solutions while amplifying the right ones. The result is a much more efficient process that can solve complex problems in a fraction of the time it would take a classical computer. However, quantum computers are still in their early stages of development. Researchers are working on improving the stability and accuracy of qubits, as well as scaling up quantum computers to handle more complex calculations. Right now, most quantum computers are limited to a relatively small number of qubits, but that's changing rapidly. Current applications of quantum computing.
While quantum computing is still in its infancy, there are already a few exciting applications that researchers are exploring.
Cryptography. One of the most talked about applications of quantum computing is its potential to break traditional encryption methods. Quantum computers can easily factor large numbers, which is a key part of breaking RSA encryption, a widely used method of securing online data. This has major implications for cybersecurity and could lead to the development of new, quantum-safe encryption techniques. Drug discovery. Quantum computers can model complex molecules and chemical reactions at a level of detail that classical computers simply can't. This could revolutionize drug discovery, allowing scientists to design new medications faster and more efficiently. Material science. Quantum computers could help us design new materials with specific properties, which could lead to breakthroughs in areas like energy storage, semiconductors, and superconductors. Artificial intelligence. Quantum computing could provide a massive speed up in machine learning tasks, enabling AI to learn faster and handle more complex data. This could lead to advancements in fields like natural language processing, computer vision, and robotics. Challenges of quantum computing. While quantum computing has enormous potential, there are still significant challenges to overcome. One of the biggest hurdles is quantum decoherence, the process by which qubits lose their quantum properties due to interference from their environment. This makes it difficult to maintain the delicate state of a quantum computer long enough to perform calculations. Another challenge is scaling up quantum computers.
To unlock their full potential, quantum computers need to be able to handle hundreds, thousands, or even millions of qubits.
Right now, most quantum computers are still in the experimental stage, with only a few dozen qubits. There are also questions around how quantum computing will integrate with classical computing systems.
While quantum computers have the potential to solve certain problems much faster, classical computers will still be necessary for other tasks.
Finding ways to make these two types of computing work together will be crucial for the future of quantum computing. The future of quantum computing. The future of quantum computing is incredibly exciting, with breakthroughs happening all the time. As researchers continue to develop more stable qubits, improve quantum error correction, and scale up quantum systems, we're getting closer to unlocking the full potential of this technology.
In the coming years, quantum computers could revolutionize industries ranging from healthcare to finance to energy, solving problems that were once thought to be unsolvable.
But for now, quantum computing remains an emerging field, with plenty of research and experimentation still to come.
As we continue to learn more about how to harness the power of quantum mechanics, the sky's the limit for what quantum computers can achieve.
Conclusion. So, what is quantum computing? It's a groundbreaking field of technology that leverages the strange principles of quantum mechanics to solve problems faster and more efficiently than classical computers ever could. While there are still challenges to overcome, the future of quantum computing is incredibly bright, and it's something we'll all be watching closely in the years to come.
If you found this video helpful, make sure to hit that like button, leave a comment below with any questions, and don't forget to subscribe for more deep dives into the world of technology.
Thanks for watching, and we'll see you in the next video.